Hmm.
Yeah, so we will be seeing this example of KNN, a more practical example of KNN than what the sample problem we saw in KNN. From that, it is even a more practical example where you can see this sentences.txt. Here we have
Hmm.
30 sentences, and if you see
Hmm.
each of these field, I mean 10 sentences, the first 10 sentences are from cricket field, games field. Then again 10 sentences are from artificial intelligence field, machine learning. And the
Hmm.
next 30, the last 10 basically from 20 to 30, it is about chemistry.
Chemistry.
If
Okay.
you see, these sentences are of chemistry, these sentences are of artificial intelligence till 10 to 20. Hmm.
Hmm.
And these sentences are of cricket.
Yeah.
Okay. Now, the problem statement is given a text sentence, any text sentence, not only these 50, given any text sentence, can you classify what is the category of this sentence? Which area it is belonging to? I mean, if I am talking about some sports, games, or something, it should say that, okay, it is cricket. I mean, this is my
Hmm.
training data. So right now I am only considering cricket, machine learning, and chemistry. Only these three topics. So
Hmm.
whenever a text sentence will come, you should be able to tell which of these three topics is that one. I mean, that particular sentence
Sentence.
which I am testing. So in order to do this, this sentence here also I have put. Okay, here also I have. I'm showing the same 30 sentences. Now this is one of the application which I have written down in order to show you how this KNN works. Okay, I will first maybe run this application so that at least uh, you will get to know how it is happening and what actually it is doing. Yeah, it is very easy actually, and like that you can actually go for building maybe 10 20 classification and categories. You can, maybe I will send you this code. What you can do, you can make it for 5 class, 10 class, and see how it is working. Okay, you see, uh, can you read this? There are 10 sentences of 3 classes on which KNN is performed. This I'm
Hmm.
just printing somewhere. Cricket, AI, and chemistry. Now, below 3 sentences will be predicted against the learned neighborhood. The first sentence is chemical compounds are used for preparing bombs based on reactions. Now, this particular sentence is not there in training data. It's not there in these 30 files. If you
Hmm.
see the chemistry lines, this particular sentence, chemical compounds are used for preparing bombs, is not present here.
Hmm.
I mean, this cricket is a boring game where only batsman enjoys the game. This sentence is also not there.
Okay.
Machine learning is the area of AI. This is also not here in this. So three examples I have taken and see what is my model predicting. First sentence predicted to be in class
Chemistry.
chemistry. So this has been detected as chemistry. This has been detected as cricket, and the third one has been detected as AI. And
Hmm.
and if you see the we discussed about confusion matrix, right?
Yeah.
If you remember, we discussed about confusion matrix, like the true, the
The first one.
actual, what is
Hmm.
actual and what is predicted. So the
Hmm.
diagonal, see, this is the confusion matrix with basically.
Hmm.
The diagonals are showing the true things, like
First one.
actually it was chemistry, predicted chemistry also. Actually it was
Hmm.
cricket, predicted cricket also, and actually it was, like, I will tell you how. It is something like this. See, If you remember confusion matrix, it was supposed to be something like this, right? Suppose here is cricket,
Actual.
AI, and
Chemistry.
chemistry. Like cancer and no cancer. Now there are three levels actually, and
Mm-hmm.
this is like actual. Now
That
here,
one is pretty. Yeah.
yeah, cricket, AI, and here is chemistry, and this one is basically predicted, right?
Predicted. Mm-hmm.
Hmm. Now, so cricket, actually it was cricket. How many of them was predicted as cricket? One.
Wow.
AI, how many was AI actually and how many was predicted AI?
One.
Yes. So how many was AI and predicted AI? One.
One.
Rest are zero. There is no misclassification here. Chemistry was also one,
Mm-hmm.
so it was predicted very correctly, so it will come here. So multi-class confusion matrix are meant like that, okay? So I am basically doing that. Now, now we will go line by line, okay? Because I mean we will see the how this Python code is running and how I have written the Python code. You can also write the same way. Maybe I would suggest you, in order to do practice, maybe just try increasing the class. I mean, I have taken 30 sentences. Maybe you can take 50 sentences, add 10 sentences more of some field. Some field you can take, any field, like you can take some politics field, maybe some BJP or Congress type of field you can take, and just add 10 sentences from there. And also at the same time, then again you can take some other field, um, like which field you can take, medical field, that is again totally a different field, right? So
Mm-hmm.
medical field, and say you can take and just add 10 sentences at last, and then uh, follow the same program which I have written, and maybe you have to change little bit somewhere, and then you will be able to classify between five categories, okay?
Mm-hmm.
You can test on some new sentences. Okay. So what I have done here is, see, from here I'm doing not it's not anything very big, but yeah, it's very simple. See, here I am just printing. I mean, I will start with line number 29, then I will maybe go up. Okay.
Okay.
See, from here I am starting. There are 10 sentences of three class on which KNN is performed. Okay. And this cricket, artificial intelligence, and chemistry. This I have just, this part it is printing, na?
Mm-hmm. Yeah. Yeah.
This I have just printed, nothing else. Now this is the sentences.txt file, that path I have taken.
Mm-hmm.
Okay, and then what I have done is, like, I have taken a list. Have you read about list in Python?
Yeah. Yeah. No. Yeah.
Yeah. So how do you write? I mean, see, if I say, how do you write a list and append a list? So if you see here, suppose I took a list like this.
Mm-hmm.
This is an empty list, isn't it?
Mm-hmm.
Now if I append here,
One.
suppose I append your name. See, now the list has one
Mm-hmm.
element. Now
Yeah.
again if I append my name, see, my name has also come. Okay.
That's two. Yeah.
I mean, I can go on appending anything. I can go on appending any number of names. Suppose I appended another name. See, three names has come, right? So And how do you access them? How do you access this list? Suppose this list name is A, right? So A, suppose you have
Mm-hmm.
to access Bharat. So A 0,
A0, yeah.
A1 Abhijit, A2
Mm-hmm.
Nancy. So it's like you can access this list. Now, if you have to see how many elements are there,
So, oh, length, oh yeah, length is 3, yeah.
how many elements are there? Length is 3, right? So that's what this is basically a Python
Mm-hmm.
list. This is a Python list. I can do something like this also. See, I have appended a whole line. Can you see?
Mm-hmm.
Whole line I have
Yeah, yeah.
appended. This is a Python list. So basically my purpose here is what I am going to do in this basically. I want to read this file, the 30 sentences were written where. I want to read this file and then I will line by line I will append it in a list
Mm-hmm.
so that I will get the whole 30 sentences at one place. At in a
Mm-hmm.
one variable, all 30 sentences I will make a list. So see this. Here sentences are this and I have opened the file with like this you open the file, right?
Mm-hmm.
You can also, I mean, you can also do like you don't give this path here.
Yeah.
You don't
Select,
initialize,
right.
huh?
We can select sentence.txt at the open file.
Huh. This also you can do, right?
Mm-hmm.
So I have opened the sentence.txt file, and then if you see, this fp is basically the file pointer of this file, okay?
Mm-hmm.
When you read a file, when you open a file in a read mode or a write mode, fp basically points to the start of file where it is starting. So from that fp you can read it line by line for line in file pointer. So it will print line by line. Okay. You
Mm-hmm.
can maybe you can see printing it. Print line. Okay, I will just print like this. See now after see all these lines have come, isn't it?
Mm-hmm.
See, there are 10 sentences of 3 class that was earlier printed, and after that, if you see, all these 30 sentences have been printed till here, isn't it?
Mm-hmm.
So that's what like, and this printing is going line by line. If I will break here, na, if I will loop, I will break the loop here. You know the break statement, right? Break is used
Yeah, yeah.
for breaking any loop. So if I
Stop.
break it here, you see, shit man. Python w.exe has anyway. You see here, if I break here, only one sentence was there. Cricket is a bat and
Mm-hmm.
ball game played between two sentences. The first sentence only came, isn't it?
Yeah.
So, so that way, this I have to restart the spider. But yeah, so basically that way you can just print maybe only sentences and you can see how these sentences are printed. Okay, anyway, so where was I? Yeah, so this break we won't do, this printing also. So line by line basically it is getting printed, and what I am doing from this, I mean see each sentence here, whenever you end this sentence here, there is a slash n, a new
Some
line character,
space. New, yeah.
a new line character, so that it goes to the new line. So that for removing that new line character I am using this strip.
String function. Yeah.
Yeah. It's a function. I will write here to remove the new line character. Okay. Now, with this, I am, and now finally in the list I am appending the things. Okay.
Yeah.
Now, in these files, if you see, in these files, if you see, there are a lot of this file you just check, or from here you check. If you see this, there is. Can you see the digits in here?
Delete.
There are digits there. I mean, you see this kind of thing, and there are a lot of
Yeah.
punctuation marks
Digits.
are also there.
Mm-hmm.
There are a lot of punctuation marks, digit. You see, there is something called as stop words. Okay, stop words are like, if you see, there are a lot of words like of, a, and, the, to, for. These kinds of
Mm-hmm.
words are there, which will never help you in categorizing the sentences. If you see this particular 30 sentences, and if you read these lines, you see there is, to, a, am, are, the, are these words going to help you in categorizing the category?
No, no.
Of course not, right? Because they that does not mean anything in the context, in the category. So basically what I am saying, I have to pre-process the sentences now. I have to do pre-processing. You remember the very first session when I was taking a demo class, I told you that how do you approach a machine learning problem. So first you have to get the data. If you remember there, I told you first you have to get the data, then you have to do pre-processing, right?
Mm-hmm.
Cleaning. Then you have to get your features. What are the features you are going to extract in order to identify something? Then you have to train it, and finally you have to test, and finally you have to again improve.
Yeah.
This was basically a pipeline which I showed you how you approach a ML problem. So now we have data, but now we see these comma, punctuation mark, these things for human readability we will do. It is done for English grammar or human readability. But if you actually see, in categorizing the classes, whether it is cricket or AI or chemistry, it will never be used, isn't it?
Yeah.
I mean, are the punctuation mark and digit going to help in the category? Nowhere. So,
No. Yeah.
in pre-processing, the first task is to remove punctuations. Now, in punctuation, everything will come: dot, comma, this, bracket, this bracket, any kind of bracket, anything. All these things will be punctuation. Then, second, remove digits, isn't it?
Mm-hmm.
Third, there is something called as stop words. So you have to remove the stop words also. In English, if you see, the stop words are those words which are used for human readability, but it will never contribute even a single percent in your classification. Like is, am, are. See,
From.
the stop words are
Mm-hmm.
like is, am, are, I, we. uh, then articles a, n, the, this, that, these, those. I mean, maybe these kinds of words. Okay.
Mm-hmm.
So these stop words are also removed. And finally, there is a very popular, phenomena called as stemming. stemming, or it is also called as lemmatization. What it is called?
Lemmatization.
Lemmatization. Lemma, you know, lemma, then tization. Okay. Now stemming is what? It's a very good concept. In English, if you see, suppose I will tell you example. Say play. This is plays. Play. Played. Playing.
Reading.
Player maybe. So what do you think? All these words will be same for, I mean, if you talk about that, okay, this play is related to games or cricket or whatever. So such words, if you see, these words will be contributing the same thing or the other different things.
The
I
same
mean,
thing.
yeah, for our readability purpose, we will write different forms of these verbs. But actually, if you see, in this particular objective, classification objective, all these words are same. They will contribute same, but they are written in different form. I mean, they all are written in differently. So everyone will be taken, considered separately if it is like this. If they are taken like this, every word will be considered as if these four words are different words. So in stemming, in lemmatization or stemming, what we do, we will convert all these four words to a basic word called play.
Yeah. Yeah.
Yeah. So the conversion of words into their basic form is called stemming. Okay.
Mhm.
Now all these four things we have to do. Now, word by word or line by line, it is, of course, you can write a code from scratch which can do all these three things with using regular expression or something. But there is a very famous library in this text analytics area, in text processing. The library is called NLTK, Natural Language Processing Toolkit. Natural Language Processing Toolkit, NLTK. That NLTK library is very famous and it is most widely used for doing these things. Okay.
Mhm.
Now, in the Python code, if you see, this was the sentences, right, which I have made list. Huh?
Yeah.
I made a list of 30 sentences, right? So this was the sentences. Now I am again iterating through each sentence. Again I am iterating through each of these
Each.
sentences, and the idea behind iterating is to cleaning the text sentence so that the punctuation marks, stop words, digits are removed.
Mhm.
This is my idea to do in this particular, in this whole loop. My idea is to do this so that I can just remove punctuation marks, stop words, and digits. So I am iterating through each sentence in this sentences list, and then I am calling a function called as clean sentence. What is the function? Clean
Clean
sentence.
sentence.
So clean sentence does what? It will take the sentence, each sentence it will take, whatever it is coming, and it will
Mhm.
break that sentence. I mean, it will break it into words. Okay.
Okay.
And then in words it will do, I mean, everything it will break separately. It will break, and then what I am doing is every word separately it will process, whether it is stemming or whether it is just checking that you are in the stop word list or not. If you are in the stop word list, you will be removed, like that. So once this sentence is is cleaned, this cleaned will be a list of words which are valid words in the sentences. So that you again join to make the whole sentence. I will tell you what is this joining do. Suppose I take name. Okay. So suppose there is a, so suppose your name is there. Okay, let's say my name. Okay. Okay. And I suppose I give my title, say sing. Huh?
Mm-hmm.
Fine. Name is this and title is this. Okay. Now
Mm-hmm.
what it does is, okay, I should actually have, okay, fine. A we have, na. See,
Mm-hmm.
can you see this A?
Mm-hmm.
Now this A has 4 items. Forget about name and title. I mean, I have to make a list then. But forget about that
Okay.
name and title. Here you just see this A is a list, isn't it?
Mm-hmm.
List of words you can say, or whatever. So what I can do with join is, see, I will say that you join with this space dot join, and I will pass A here. You see what has happened? A
Okay.
was a
Okay.
list.
Okay.
So all the elements of list are concatenated, are joined together with this particular gap. I mean this particular delimiter.
It remove the commas, right?
No, it does not remove the comma. What it does, it was a list of 4 elements. So it
Mm-hmm.
took each element and just concatenated. Concatenated means just,
Yeah.
I mean, extended
Added.
it. Basically, from words, it is making it a string as a
So,
sentence.
okay. Okay. Yeah.
Okay, now if you see, now if you take this sentence, now
Mm-hmm.
this is a string. It's not a list anymore.
Yeah. Yeah.
Earlier, this A was this, and if I would have done, see, if I would have done like you join it with nothing, without any space, so then this would be the result. See,
Mm-hmm.
everything concatenated without any space. If I
Mm-hmm.
would have done that, okay, you concatenate with equal to, see, it would do equal to.
Mm-hmm. Okay. Yeah.
And basically, after all, it is forming a string. Okay. So that is what I am also trying to do here. This cleaned is basically a list of words which
Mm-hmm.
are coming. So I am basically joining it and making it again a sentence, like earlier I had sentence. So then that thing I am making. And then this line number 43 especially I have written for digits, to remove digits
Okay.
from sentence, to,
Remove digits. Okay.
yeah, digits. How it is doing? Can you see this? This re is basically regex. Regex, have you heard or not? Regular expression.
Rejects.
Yeah. Have you heard regex somewhere? Regular expressions.
No.
Okay. Okay. So regular expressions are like something called as pattern matching is there. Okay. Pattern matching means, suppose I have a sentence. Suppose I make a sentence as a string basically. There are 20 people in the park. In the park. Okay. Now this sentence is there. Now if I say that I want to replace wherever in the line there is 20, make it 30.
Okay.
So what you do? you will use a pattern matching algorithm. I mean, pattern matching algorithm means you will just check all the characters, all the duplets, maybe two characters together. You will check, and you will check whether it is 20 or not, isn't it?
Mm-hmm.
And if you found 20, you just replace it with 30. So regular expressions are used for matching things. I will tell you. See, I have imported a regular expression library which is known as RE. Okay.
Mm-hmm.
Now this RE, what I will do, see, RE dot sub. Sub means substitute. Sub means
Substitute.
substitute. Now here you have to write whatever in this particular thing, na R, this in the first parameter of this function, RE dot sub, the first parameter. Here you have to write what pattern you want to match. So if you want to match digit, you have to write like this percent slash b. And if you want that any number of digit, I mean whether it is 2 or 20 or 200 or 240, I mean any number of digits should come, I should match. So if any number of digit will come, I will match. So you have to write plus. So even if the digit is occurring multiple time or any digit, I mean digit are coming in sequences, you can catch them all.
Mm-hmm.
So with this you will be catching, and then as this is a substitute function sub, so what you will be doing with what you want to replace it. So I told you wherever I am finding digit, I said that replace it with 30.
Mm-hmm.
So I will place 30 here. Okay, sorry. And then also you have to give the list, I mean the sentence. So I am saying in this sentence, search for any digit and replace it by 30.
Okay. Mm-hmm.
Can you see now?
Yeah, I can see.
There are 30 people in the park. Earlier it was there are 20 people in the park. So you can match the pattern and change the things or maybe remove things. If you want that I have to remove the digit, just don't put anything here. See, the digit are gone. There are people in the park. Okay.
Mm-hmm.
So I hope you understood this regular expression what it is doing. Something, see here,
Yeah.
it's only digit. Okay, here it's only digit, but I'm telling you, like in lot of places, you may have to write maybe 30, 40 such filters. Okay,
Okay.
just wait, I will come.
Mm-hmm.
So in various applications, maybe you have to write maybe 20, 30 such such filters. Okay, so
Mm-hmm.
this is basically digit remover I am doing, and this again I have taken a list of clean sentences. Okay,
Okay.
so in this clean sentences I am again appending that. Fine,
Yeah.
you understood or not?
I understood.
Now it's very easy. See, this train clean sentences, it will be a list of 30 sentences
Only.
where all the where all the character, I mean punctuation marks and digits and everything will be removed. Would you like to see this how it looks like? See, I will show you.
Mm-hmm.
See, this is how it will look like. Train clean sentences.
Mm-hmm. Yeah.
See, cricket. Now cricket, earlier it was actually, the first sentence was cricket is a bat and ball game played between two teams of 11 players on each on a cricket field, right? Cricket is a bat and ball game. It was like that, right? See what has it become.
Mm-hmm.
Cricket, bat, ball
Cricket
played
ball,
between
game played
11
with
player in the
two
cricket.
level player cricket.
So you
Okay.
see, all the and, is, a, am, those things are removed, isn't it?
Mm-hmm.
So this is what I was talking about. I mean, stop words are removed, and
Yeah.
yeah. So that way you can do things.
The stopwords are removed from the clean function, right?
Yes, clean function, clean. I will come to that clean function also. I will come to that clean function.
Mhm.
So this is how your sentence looks like now, and you see all the digits and all everything would have gone. See, there is no digit here.
Mhm. Yeah, yeah. Not digits, yeah.
Earlier in this sentence, 14th sentence natural language processing there was 77 here.
Yeah.
And now if you
But,
see, uh, maybe
um,
somewhere 14 sentences will be there. Artificial intelligence exhibited somewhere. There is no such 78 or 48 anything.
mhm.
Okay, so that's what
For
I
everything, there
was.
is a U here. U for every starting line. U.
Huh?
For every starting in the print function, there is a U in the
Yeah,
every
yeah,
starting
yeah.
line.
Yeah, of course, yeah. U is there. Basically, this is a list, right? This is
Mm-hmm.
clean sentence is also a list, right? So that U is, do not
Yeah, yeah.
consider that U is part of the sentence. This is just telling that this is
Okay.
the first element of list. When I showed you here, see, when I print A, there is the inverted comma, right? This
Mm-hmm.
does not mean that this is a part of this word. I mean, if you will print
Okay.
A0, it will show you Bharat, but actually this Bharat is, I mean, as a string it is only Bharat. I mean, this inverted comma is just showing that it is a string. And here, the
Mm-hmm.
U only shows that it is a Unicode character. I mean,
Okay.
you might have heard, maybe read, or maybe you might have seen this UTF-8 characters are there. A lot
Mm-hmm.
of time in on web pages also. This thing have you seen?
Mm-hmm.
UTF-8. This is actually the character encoding which is used in languages, in Java or in Python. I mean, the character encodings are there for writing any program or writing any string basically in any language. So character coding, this Unicode character coding is very famous. So it is just telling that all of these are just the Unicodes. Okay.
Mm-hmm.
So once I have cleaned these, now you
Mm-hmm.
see, um, what I am doing is I am passing this train clean sentence into a TF-IDF vectorizer, isn't it?
Mm-hmm. What is
Yeah, I mean, what I am doing is I am passing it in a TF-IDF vectorizer. I will tell you what it does. I mean, just maybe you don't, I mean, as of now, you don't need to know all this, but yeah, I will tell you little bit of this. TF-IDF vectorizer is again a library package. What it does, it will convert your sentence into some numbers, into numbers or say values. Because you see, directly text you cannot process, na? You should get some numbers, you should get some digit values that you can compare
mm-hmm.
and do, right? Directly sentences you cannot do. I mean, how will you process words? I mean, how will you find the Euclidean distance between? See, in here, it was easy to find the distances, that what is the distance, what is the class level and all, like which are the k nearest neighbor. In the k nearest neighbor, I told you that Euclidean distances are used, isn't it? So those Euclidean distances and all, you know that okay, if this is the value, this is the value, I can calculate that. But in text, when it is all text, how will you know that what is the value, isn't it? So this text has to get converted into uh, numbers or values. So this IDF, it is actually the full form is term frequency. The term frequency and inverse document frequency. It is a very important feature in text analytics. In text analytics, this is most commonly used feature, which will convert, basically, it's a technique to convert sentences into digits, I mean values. So that TF-IDF vectorizer I am taking, and I am transforming my X. X is basically what? X will be the, you understood what will be the X? X will be something like this. You have 30 sentences, 30 into some number of columns, maybe say 200. So for each sentences, each of the 30 rows, there will be 30 rows in here. For each of these sentence, it will form some 200 dimensional values. 200 words, I mean values, it will generate. TF-IDF, okay? And now if you see in here, so that matrix is known as X here. That matrix I am keeping it, storing it in X, okay? And now, as you know, in this sentence.txt, you know that first 10 are cricket, second 10 are AI, and third 10 are chemistry. The first 10 sentences, the last 10 sentences. So what I am doing, I am creating a Y train. So X is basically the data, Y is the label. So I am calculating the labels here. You see, np.zeros 30. You know what np.zeros does?
Yeah, it creates some 30 zero values. Yes, 30 zeros. The list, I guess.
Yes. So it creates an array of 30 zeros. Now, from 10 to 20, I am passing 1.
Okay.
So if I take this array into, say, num is nothing but 30 zeros. So what I am doing from num, I know that from 10 to 20, I have the field chemistry, which is first class. Sorry, AI, which is first class. And from 20 to 30, it's the second class. So if you see num now, the first 10 are zeros, the second 10 are 1, and the third 10 are 2. Okay? This is the labels which I have created. Okay? So similarly, here the labels are created. And then you do nothing, like here in the temp you have done neighbor fitting and all.
Okay.
Similarly, here also you are just taking k neighbors as 5, and you are taking your model and training it, and then you have then what has happened, you have taken this test sentences. These are the sentences which I am going to test. Okay.
Test, yeah.
Yeah, these were not included in those 30 lines.
Other ones, yeah.
So same thing has to be done again. Again, these test sentences I have to go through the same thing: cleaning, punctuation removal, stop word removal, digit removal, and then test clean sentences I have to form, isn't it? Because the same features,
Yeah.
same pre-processing steps has to be done on the testing also, like the training happened.
Yeah.
Now, with the same vectorizer, you see, we got this TF-IDF vectorizer we have initialized here. We have got this model, right?
Mm-hmm.
With the same model, I am going to transform these three sentences into, again, values. Like there was X, so similarly here it is test. Okay?
Mm-hmm.
And then in KNN, you see, we used to do this model.predict, right? Ne.predict here. And in
Yeah.
predict, you have to give what data you want to predict. So here also I am doing, see, model.predict, and then I want to predict for these three sentences which I have
Mm-hmm.
converted into values.
Mm-hmm.
And I will get the predicted level here. Okay?
Mm-hmm. Yeah.
Yeah, predicted level I will get here. Okay? So I am printing it here. The first sentence is to be predicted in predicted level 0. Okay? Then
Mm-hmm.
predicted level 1. And the third sentence to be predicted in predicted level 2.
Mm-hmm.
And I have actually created a labels which corresponds to 0, 1 and 2. 0 is cricket, 1 is AI and 2 is chemistry. Okay?
So it's chemistry. Mm-hmm.
So what I am doing, whatever you predicted levels will tell me 0, 1 or 2, right?
Mm-hmm.
So same index I am accessing of this labels list. What I am trying to do, I will show you here. We had A, right? We have this list. Okay. Bharat, Abhijit,
Mm-hmm.
Nancy, and maybe this is a Python lib. We have this thing, right? Suppose
Mm-hmm.
I will write A1. It will be my name, right? Instead of
Yes.
writing it like this, A1, can I write something like this? Suppose there is another list, say B, uh, 0, comma 1, comma 2, comma 3. Okay, fine.
Mm-hmm.
Now I am to write A1, that is Abhijit. Instead of writing like that, I am writing B1. B1 is what?
B1 is 1.
1. So now A1 will be what? Abhijit, right? See.
Abhijit, yeah. Okay. Mm-hmm.
Basically, you are getting the index from B1 value and then you are writing the label from A1. A.
A1, okay.
Suppose I will write label is equal to, suppose I make a list of three things: cricket, AI, and chemistry. Now, what I am doing, label is equal to, so
Table of,
label I am accessing,
table of
and through I am accessing it through B.
A, D of 1 or 2, yeah.
So B of 2 will be chemistry because B of 2 is giving me 2 and label 2 is
2.
chemistry.
Mm-hmm.
So like that I am trying to do the same funda here. You see,
Yeah.
lot of text is there, so maybe it will be seem messy, but see, labels, inside the labels accessing, I am doing predicted label 0, isn't it? And
Mm-hmm.
this np.int is actually used because this predicted level 0 is a float number,
Okay.
decimal. The decimal cannot be used to, I mean, see, if I write labels, it will print me AI.
Mm-hmm.
If I write 1.0, then what will happen?
Error.
What is happening?
Error.
Error. List indices must be integer, not float. Okay. So what I have to do if such, and I cannot prevent it. I cannot. I mean, it will come as float only. So what I can do? I can do np.int. I will convert this float into integer like this.
Integer.
Double
Okay.
open friend.
Okay.
Okay. So same thing I am doing here, and like that you can, you will get the predicted labels which it is printing actually. See, first sentence to be predicted. These things are there, na? So actually it is printing like that, okay? You see. First sentence is to be predicted in like chemistry. Now how this chemistry is coming? I have this labels. In labels I am accessing the predicted level. So predicted level is 0. So when predicted level is 0, from labels 0 it will find and it will say that okay, it is cricket. You got the whole funda?
Yeah.
Now little bit of more stuff in this. See, all this, first of all this TF-IDF vectorizer, K nearest neighbor, then this NLTK thing, stop words and word net lematizer, then string, regular expression, numpy, confusion matrix, everything, all these libraries I am importing. Okay, so you might have seen the usages. RE you have seen, I have shown you that here it is. Similarly, NumPy is used. I show confusion matrix also. In confusion matrix, you don't have to do anything. In confusion matrix, this is predicted labels, na? This confusion matrix is what? It is actual versus predicted, isn't it? It's a matrix. Actual, what was actual, what is predicted. So you have to just see. This is the predicted, what has come from predict, and this is the actual which I have written. That the first sentence is from 2 class, second sentence is from 0 class, and machine learning is from 1 class. So if I just pass the y-test, the actual and the predicted, it will automatically calculate the confusion matrix for you. This is again a function, I mean the library, it's in matrix package of a skiller. Now last thing I would like to tell you is about cleaning.
Yeah.
I told you that NLTK library is there. So from that library, I have taken the stop words. I have taken the list of, I mean from this string, I have taken the list of punctuation letters. There are punctuation letter like comma, inverted comma, bracket, and those things. So that punctuation letter I have taken. And also I have taken a word net lematizer which will do the stemming part. Okay. So now in this cleaning, if you see, this clean sentences I was calling, na?
Yeah. It was yeah.
This clean sentence is basically from here. And in this definition, you see I am doing nothing. I am passing one sentence. See, here I was passing, in clean I was passing one sentence.
Yeah.
So this sentence comes here in this parameter, and I am doing nothing. If I am splitting it in the see, with split, I am splitting the whole sentence into words, and if these words, it is in stop. Stop basically contains all the stop words of the English language.
Yeah.
So if it is in the stop, you will remove it. If it is not in a stop in this list, then you will consider it as a list. See, can you see this bracket?
Yeah.
This is a brackets of list, right? So if it is not in the stop words, you will consider them, and then finally you will join them and make
Join them.
a string. That string will be stop word free string. Similarly, in this stop word free, again you will find each and every character, and you will find if it is in punctuation mark. If it is not in punctuation mark, well and good. If it is in punctuation marks, you will remove it.
Exclude.
Okay, that will be removed. And then this is for lemmatization. Again, every word you will split, and again you will split. I mean, you will split, and then again you will uh, lemmatize it through the lemmatizer, and you will join. I mean, see, you have to maybe see this one-liner sentences. I mean, I have more practice on Python, so I have written it in one go. Okay, you can write a small for loop instead of this, which can do things for you. I mean, Python is a very flexible language. You can write a lot of things in just one line. So in just one line, I have merged a lot of things. But yeah, you can write a small code for doing this. I mean, a separate for loop you can write. Okay. So now when you have this stop word free, punctuation marks, and then lemmatization is also done, then you will return these words. I mean, each sentence you will again split in words, and then these words you can return here.
Okay.
This clean sentence will clean everything, and it will return the words here. Okay, understood?
Yeah.
Okay.